Limits. Limits in calculus are just like, I guess you can say limits in life. If you have a grocery budget, for example, that you want to only spend $25 this week for groceries, and so that would be your limit. That would be the as far as you want to go. So um, in determining, how many things you can buy based on your limit, you would input that limit into the things that you want to buy, and that will give you, uh, what what you can buy. So limits in calculus. If we look at this rational, the expression that we have here, we read it as the limit of x as x approaches. That arrow means x is approaching 25. So the limit of x as x approaches 25 of the expression 5 over square root of x. I'm sorry, 5 minus square root of x over x minus 25. So generally we would want to take 25 and substitute it into the equation to determine what our limit is. But if we do that, look what happens. We'll get a zero in the denominator, and we can never have a zero in the denominator. Especially if we're trying to determine the limit. So if we substitute 25 in for x, particularly in our denominator, that's where we're going to get a zero, which we don't want because a zero in your denominator makes the problem undefined. So what we have to do instead of substituting right away, is rationalize that numerator. So we rationalize the numerator. We have 5 minus the square root of x. Well, rationalizing is doing the opposite sign of what's in front of the radical. So the when we rationalize that, we would take 5 plus instead of minus the square root of x and multiply that to both the numerator and denominator. So again, we're looking at the top part of it, because if we substitute 25 in the denominator, it's just going to give us that zero in the denominator, which we don't want. So we look at the top and we rationalize. We we rationalize it by um, whatever. In this particular case, we're looking at the sign that's in front of the square root, and we do the opposite sign of that. The 5 stays the same. It's just that square root that we're really changing, and we take that and we multiply that to both the numerator and the denominator of the equation. So we look at it like this here. Multiply it to the top part was a plus, and multiply it to the bottom part. All right. So we use the FOIL method: first, outer, inner, last. So the first terms, when we multiply the first terms of the top part, we get 25. The outer terms gives us plus 5 square root of x when we multiply those. The inner terms gives us negative 5 square root of x. And then the outer terms, the last terms. So the last terms, when we multiply those together, we're going to get a negative x because, uh, and just to make sure you understand that, when we multiplied that we had negative uh, square root of x times a positive square root of x. Whenever we multiply the same root that has that same thing on the inside or the same base on the inside, it becomes whatever it is on the inside. So negative times a positive gives you a negative, so this becomes a negative x there. So that's the top part, and we're going to eventually combine like terms. But looking at the bottom part, doing the same thing, we're going to multiply. First terms gives us 5x. The outer terms gives us plus x square root of x. The inner terms, 25 negative 25 times 5. So negative, and then the last terms, minus 25 square root of x. And now we just want to look at combining the like terms. So up top we have, this cancels out. Then we have 25 minus x. Looking at the bottom part, we have 5x plus square root of x minus 25 square root of x. Okay. If we look at the bottom part further, we can take that and factor it. So, or actually, we want to group first. So we take the 5x plus the x square root of x, and then group the other terms. So put a plus sign here, negative 125 minus 25 square root of x. Then factor. So out of this one here, we can factor out an x because x is in both of the terms. That leaves us with 5 plus square root of x. Then looking at this over here, we can factor out a 25. So since the first term is negative, we're going to factor out a negative 25. So 5 negative, then that changes the signs on the inside. Now we want to factor out the common. And this all comes from algebra, so um, all of these terms that we're looking at right now is just basically coming from algebra, and that's what calculus is about. It's about a lot of algebra with some calculus concepts. So the common term that's here is 5x plus 5 plus the square root of x. We factor that out, and then in we open up our second set of parentheses, we put what's on the outside of those parentheses, which is the x minus 25. Okay, so let's rewrite this again. This is your denominator here, and we're gonna look at it from that point of view. So our numerator is 25 minus x. The denominator now is 5 plus square root of x times x minus 25. Now let's do this. Let's take the numerator, and write it with our x term first, which is negative x plus 25. And all right, and we can go one step further because we can factor out a negative from the top part of the fraction or the numerator. So we can take that negative out, and then this now becomes x minus 25 at the top part. And now look at what we can do. We can cancel, or this goes into itself one time. Now we have negative 1 over 5 plus the square root of x. All right, so we've rationalized it. Now this is our equation. Now we can take and find the limit as x approaches 25, meaning that we're going to substitute 25 into that equation and determine what the limit is. So we're going to substitute 25 in here. So square root of 25 is 5. So we're looking at 5 plus 5 in our denominator at that point. So that tells us the limit as x approaches 25 is negative 1 over 10. And that is our result. Negative 1 over 10. So the limit as x approaches 25 of the expression 5 minus square root of x over x minus 25 is negative 1/10.